This is a video on how to find the area and circumference of a circle, as well as how to find the radius or diameter of a circle when given the area of a circumference. So let's start off with the basics here. The circumference is the outside edge of a circle, and the area is the inside of the circle. So here is a screenshot of the formula sheet that's given to you on the GED test. And you can see underneath area, you have the circle, and A stands for area equals to pi times r squared. And so when we have these letters written right next to each other, that means to multiply. So in other words, pi is 3.14, and I'll show you where that is in a second, times the radius times the radius. That's what the little 2 means. Take the radius times itself twice, okay? So I'll show you how to put that little 2 into the calculator, take the square of something. Now, the circumference of a circle is really known as the perimeter. Well, I should say it's also the perimeter. It's known really exclusively as the circumference. And so there are two formulas, and I think the GED formula is a little weird here. It says circumference equals 2 pi r, and then they capitalized both O and R for or, meaning like there's two different formulas. So it's 2 times pi times the radius, or it's pi times diameter. And then here they tell you that pi is 3.14. So I always like to direct students to this one. This is the one that I like the most, which I'll explain in a second. I like one, it's just the simplest one, and I like to reinforce the if you know the diameter, all you have to do is take half of it to find the radius, which we'll practice here in a second. So circumference is equal to 3.14 times the diameter of a circle. So let's focus on the diameter and radius of a circle real quick. This is a huge part of knowing circles, but it's not explicitly called out on the GED. It's too easy at that level, but they are going to test your ability to know this. They're going to give you the diameter, and yet you're going to have to know the radius, or vice versa. So the diameter is here in red. It goes edge to edge through the center. And then the radius goes from the edge to the center. So we have some relationships here. The diameter is equal to double the radius, or the radius times 2. So to double something is to multiply it by 2. And then the radius is half of the diameter. So if you divide something by 2, that's a way of taking half of it. So if you look here, if we extend this radius out and we add another radius, right? Two radiuses here together are going to equal a diameter. Or likewise, if we just focus right here on this half of the diameter, it's equal to the radius. So in other words, if you know one, you know the other. So let's practice this. Here's a little T-chart over here. If the radius is 1, the diameter is 2. If the diameter is 6, the radius would be half of that, which is 3. If the radius is 4, the diameter would be 8. If the diameter is 50, the radius would be 25. And if the radius is 75, then the diameter would be double that, multiplied by 2. If you need to, it would be 150. So this is a really important thing to know when it comes to circles. There is a Khan Academy exercise that does this really well. So be sure to look for that at the end of the video. All right, so now again, here's just another basic question, no word problem or anything. It's asking for the radius, asking for the diameter, asking for the circumference, asking for the area. So here in black, going from the edge to the center, we have 7. That's going to be equal to the radius. The diameter is the red line. It's going to be twice that. So twice 7 is going to be 14. Now let's find the circumference. Again, there are two formulas. Circumference equals 2 pi r, or this one, circumference equals pi times diameter. I tend to prefer this one. So this is going to be 3.14 times the diameter, which is 14. So let's put that in the calculator. Let's clear this. 3.14 times 14. And that's 43.96. Now that is a linear measurement. So these are inches. Sorry, the radius up here would be inches, diameter here would be inches, and then 43.96 is also inches. That can be helpful to know the different units, that this is just one measurement. It's not squared or it's not going to be cubed. Now, the area is going to have a little 2 next to it in our answer, and it's going to end up being inches squared. That little 2 there means squared, meaning it's a measurement of area. So you have to know the radius to find the area. So pi is 3.14 times, in this case, 7 squared. Now that again is not 7 times 2, that means 7 times 7. But we're going to use the calculator. So 3.14 times 7, and then here's the little squared button in this x2 right here. You can see the little 2 that popped up. Go ahead and hit enter, and we get 153.86. So 153.86 inches squared. Now, some students do notice there is an actual pi button. So what happens if you put in the pi button? And this is why you won't see me use this, but let's do it. What if we did pi 7 squared? So we should get an answer of 153, but if you do this, you're going to get 49 pi. This is why I always recommend putting in 3.14. If you do want the decimal, you would hit this double arrow decimal. But again, you're going to see I don't use this. I think when they tell you that pi is 3.14 on the formula sheet, they're telling you use 3.14. Do not use the calculator version of pi. Here is a word problem. The diameter of the blue circle is equal to the radius of the black circle. What is the difference in their areas? So I think this is a GED level question. This one is challenging. So the diameter of the blue circle is 6.4. So let's use some blue ink here, and let's talk about the blue circle. We know that the diameter is 6.4. Now the radius is half that. So if you don't know, oh shoot, how do I find half of something? 6.4 divided by 2 is going to give you half of something. So the radius of that blue circle is going to be 3.2. Now let's take the black circle. They're going to be essentially the same size in my drawing here, but here they give us the radius of the black circle. So the radius of the black circle is 6.4, so the diameter is going to be twice that. So again, let's take 6.4 and multiply by 2. You might be able to do this in your head. If so, that's great. I am always encouraging students, get used to using that calculator. Find a calculator, practice with it, get used to using it. No shame in that at all, even if the math feels easy. Now, we want to find their difference in areas. So the black circle is bigger, right? So we're going to take the black circle minus the area of the blue circle. So we need to find the area of each of these. So here's the area, and then the area of the black circle. So we're going to find these two areas and then subtract the two numbers, and then that is going to be our answer. So what we need up here to find the area of any circle rather, is just the radius. The formula is pi times radius squared. So let's do that here for the black one. This is going to be 3.14 times 6.4 squared. So let's put that in the calculator over here, 3.14 times 6.4 squared. So the area of the black circle is 128.61. And now let's find the area of the blue circle. That's going to be equal to 3.14 times the radius of the blue circle, which is 3.2 squared. So 3.14 times, so sorry, I thought 3.2 squared. Thought I made a mistake there. Did not. Okay, now we subtract these, 32.15. So let's take 128.16 minus 32.15. That's going to be our answer. 128.61. So there's the area of the black circle minus 32.15. Their difference is going to be 96.46. And there's no units. So it's just just units squared. That would be could be inches squared, feet squared. We don't know. So 96.46 units squared is our answer. Here's the next problem. The diameter of the fence is 1.5 times as long as the diameter of the pool. If the area of the pool is 400 feet squared, what is the circumference of the fence? You see the diagram here, very simple. Got a pool with a fence around it and a little key here. So here's the steps we're going to take to solve this. Okay, step one is we're going to find the pool radius from the area of the pool using the equation a equals pi r squared for the area of the circle, which again is on the formula sheet. Step two is find the diameter of the pool by doubling the radius. Step three, we have to scale up because the fence is bigger than the pool by a factor of 1.5, so we multiply by 1.5 and then use the fence diameter to find the fence circumference. So let's go ahead and get started here. We know that the pool, the area of the pool, so here's step one, the area is equal to pi r squared, pi times radius squared. So we've got 400 is equal to 3.14 times the radius squared. Now, this is going to be two steps. Step one is we're going to divide by 3.14. And then step two is we're going to take the square root of that answer. That's how we undo this squaring. So let me change the color for each step. We're going to divide here by 3.14, divide here by 3.14. These cancel out. That's going to leave us with the radius squared equal to, I'm over here at the calculator now, 400 divided by 3.14. So let's call that 127.4. So that is not the radius, that's equal to the radius squared. So the radius is the square root of it. That's how we undo squaring. So we're going to put this in the calculator, the square root of 127.4. So what we need, if you can see me hovering over here, that is the square root button. So it's the green letter, and so we have to hit that green button first, then this button. Now we've got our symbol, square root symbol. Now we can put in 127.4 and we get, let's call it 11.3. The radius is 11.3, just rounding to the nearest tenth there. So that's step one. Now step two is to find the diameter. So the radius times 2 equals the diameter. So what we're going to do is 11.3 times 2 equals, let's just take 11.3 over here in the calculator. You might be able to do this in your head. If so, that's great. This is 22.6. Now that's equal to the diameter. All right, so now the diameter of the fence is 1.5 times as long as the diameter of the pool. So if we've got 22.6 feet for the pool, what we need to do is take 1.5 times that, and that's going to give us 1.5 over here in the calculator times 22.6. That's equal to the diameter of the fence. Okay, diameter of fence equals 33.9. All right, now the question is, what is the circumference of the fence? So if you look on the formula sheet, our fourth and final step, the circumference is equal to pi times diameter. There's another one as well, 2 pi r, 2 times pi times the radius, but we might as well use this one. Circumference equals pi times diameter. So this is 3.14 times 33.9. So we already have that as our answer. Let's just multiply it by 3.14, and that is going to be the circumference. So why would you want the circumference of the pool, or the fence around the pool rather? Maybe you're putting a fence. Fences are required. So this would be 106 feet. Our next problem says one of the above circles has a circumference of 30 inches. If there are 50 circles lined up end to end, what is the distance of all 50 circles together? So imagine this is like brick pavers, those circular pavers you walk on sometimes, and you need to have a distance, and you wonder, what if I put 50 of these together? How far will that reach? Um, so we know that the circumference of one of these circles is 30. So that means each of these is 30, right? But that's not how we go about approaching this. What we need are the diameters. We need this one. And then we're going to multiply it times 50. So this is the diameter here. And they're all going to be the same. So here's our steps. Step one is we need to find the diameter from the circumference, and then we're going to multiply by 50. And then there's the second question, but we'll get to that one in a second. So circumference is equal to pi times diameter. We know the circumference is 30. So that's equal to 3.14 times the diameter, which is what we need to solve for. So we have to undo this multiplication. So we're going to divide by 3.14 on both sides. These are going to cancel out. Ah, shoot. No, those don't cancel out. These cancel out. The diameter is equal to 30 point, let's just call it 30.0. Getting ahead of myself here, divided by 3.14. So we've got, let's call it 9.6. Let's round up to the nearest tenth. So that means this distance here is 9.6. Then this is 9.6. And then this one is 9.6 for a total of 50 of them. So what we need to do is take 50 times 9.6, and that will give us our full length. So let's do 9.6 times 50, and that was going to be equal to 480 inches. Okay. Um, what if we wanted to find the area of all of those circles together? So they give us a circumference. We ultimately need to find the area. This is the type of GED question I think comes up a lot. They love to give the area, ask for the circumference, or the opposite in this case, give you the circumference, ask for the area. So here's the steps for going about answering this one. We're gonna take half, I spelled that one wrong, half of the diameter equals the radius. So we're going to take our radius of 9.6, and we're going to take half of that, which let's put that in the calculator. 9.6 divided by 2 is 4.8. So now we know the radius is 4.8. Now we're going to use area equals pi times radius squared to find the area of one circle. Then we have to multiply that by 50 to get the area of all 50 circles. So step 2 here, area is equal to pi times radius squared. So that's 3.14 times 4.8 squared, and then times 50, but let's take it in two steps. So 3.14 times 4.8 times the radius squared. Here's the little squared button, little x2. You can see the little 2 that pops up. That means 4.8 times 4.8, not 4.8 times 2. So that's 72, and then there's 50 of those. So let's put that answer here. This is for one circle, 72.3. Okay. Now we need to multiply this 72.3 times 50 to get our final answer. So 72.3 times 50 is 3,615 inches squared, meaning it's a measurement of area. And that is our final problem. The other thing I like to highlight, this video is going to go right here on my website, passtheged.org. Here's area and circumference of a circle. These are Khan Academy exercises, which I think do a great job, especially the circumference and area challenge at modeling GED type questions. These ones here are easier, probably too easy for the GED, but they are a great way to build up to the circumference and area challenge. Best of luck to you.